Okay, so I chose to present number 10 because it's very short and they give you a formula, but they really give you nothing else. So it's very difficult to kind of figure out what to plug in where, okay? The idea that you're going to have to use behind number 10 comes from those properties of exponents again. That is going to be very important, knowing when do exponents become, when do exponents allow a number to become a fraction. Okay, so let's review that first. So if I have something like x to the negative n, okay, just keeping it really generic, that is the same thing as 1 over x to the positive n power. So negative exponents mean I'm going to put this factor in the denominator of a fraction. Okay, now I'm ready to start number 10. The half-life of radium is 1600 years. Okay, so let's record that. Half-life is 1600 years. So half-life, that's how long it takes for radium to decrease its initial amount to half of that size. So if I start with 5 milligrams of radium, I'm looking for 1600 years later, that 5 has become 2.5 milligrams of radium, okay? And then it does give you this nice formula. So it says the quantity at time t, right? This is function notation. I'm going to plug in a time and output a quantity is an initial quantity, okay? Q with a subscript 0, that's just Q naught, like NaUGHT. So that's just an initial amount. What's going on when time is 0? That's what that 0 means. That 0 is not a number. It is a subscript on the Q. Okay, and then there's more, times 2 to the kt. Okay, and the question is all about bind k. Okay, so that's my goal, is to isolate k. Okay, but look at all those unknowns floating around there. That's a lot that we really don't know what to plug in. So I'm going to come back here and say, okay, if I know the half-life is 1600, and I know I start with Q naught. Okay, so let's record that. Start with Q naught. Then 1600 years later, how much is left? Okay, well, it's a half-life. So if I started with 10, 10 is going to become 5. If I started with 100, 100 becomes 50. I'm starting with Q naught, so Q naught is going to become half of itself. Okay, 1600 years later, I have half remaining. Okay, so this is my starting value, this is my time, this is my ending value. I'm going to plug all that back into the formula. So 1/2 Q naught equals Q naught 2 to the k, and the time is now 1600. All right, so I went from a ton of variables to maybe only 2. I don't know Q naught, I don't know k, my goal is to find k. It's okay that we don't know Q naught. Look at what's going to happen. If I divide the right-hand side by Q naught, and do the same thing on the left-hand side, cancel, cancel. They just disappeared. So I've got 1/2 equals 2, and let me write the coefficient first and then the variable, 1600k. Come up here. All right. I am looking at a fraction on the left. This is 1 over 2 to the first power. If there is no exponent written, it is an implied 1. So 1 over 2 to the first is 2 to the negative 1. So I'm going to rewrite the left-hand side with my properties of exponents. 2 to the negative 1. Right-hand side, keep exactly the same. Now that I have the same base appearing on both sides, that's a 2, that's a 2, different exponents, but equality in between, I can set the exponents equal. So I've got negative 1 equals 1600k, and I'm one step away from finding out what k is. Divide by 1600, and k is negative 1 over 1600. So I did highlight the fact that we have to know those properties of exponents. And then there is also this additional rule that if you have the same base but different exponents, you can set the exponents equal. Okay, so that gives us our final answer of negative 1 over 1600 for number 10.